So everything that we've done up to this point in chapter 1, all of the numbers we have talked about have been rational numbers. Whether they're whole numbers, integer, or fractions, all of them have been rational numbers, okay? Now we're going to go into something that's called irrational numbers. So let's first go over what the definition of a rational number is. A rational number, if it's rational, it's a number that can be written as a fraction, like m over n, where both m and n are integers. Okay? That's what it means for a number to be considered rational. So that's why 5 is a rational number, because you can write it in this format, 5 over 1. Negative 5 is also a rational number because you can write it in m over n fashion by putting it over 1. In fact, any whole or integer number you can put over 1 and create a fraction where both the numerator and denominator are integers. And then if you just have a fraction like this, let's say 2/5, well, this is already in ratio or fraction form. So by definition, that's also rational. And then we went over certain kinds of decimals that were also rational. So for instance, a decimal that either terminates, meaning ends, like 0.4 that ends, you can always turn this into an m over n fraction. So that's a terminating. Or you could turn it into, or you could have a repeating decimal. And repeating decimals can also always be turned into m over n fraction form. Now, while we have turned terminating decimals into fractions, and we've learned that in class, what we haven't learned is how to turn repeating decimals into fractions. So I'm happy to make another video on how to do that. We're not going to cover it in this course, but just know that if it is a repeating decimal, it absolutely can be turned into a fraction. If you're curious what 0.4 repeating is as a fraction, it turns out it's 4/9. And there's a way that I could show you how to do that in another video, but suffice it to say, this is equivalent to this. 4 over 9 is an m over n, integer over integer, so this is totally rational. Okay, now let's move into numbers that are not rational. And if you want to say not something, not rational, the prefix that you can use is this, I or IR. That means not. So think of the word relevant, stick an IR in front of it, and you get irrelevant, meaning the opposite of relevant, not relevant. So this is a really good prefix in order to turn a word into its opposite. So now we're dealing with the opposite of rational numbers, which are not rational. So if the definition of a rational number is a number that can be turned into a fraction m over n, then that means that an irrational number is a number that cannot be turned into a number or a fraction in an m over n fashion where m and n are both integers. So what kinds of numbers cannot be turned into this form? Certain types of decimals. Now the decimals that we have been working with before are rational decimals. They either terminate, or if they repeat, or if they go on forever, they repeat. So irrational numbers are decimals that go on forever, but never repeat. There's no repetition. So pi is an example. It is a number, a decimal that goes on forever, and you might know it to 20 places or 30 places, but it goes on for an infinite number of places, and it never repeats. So it starts off 3.14159 dot dot dot, but this dot 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 doesn't mean it repeats this. It means it goes on to random numbers forever, okay? So pi can never be reduced to a fraction in this m over n form, where m and n are both integers. There's no way to do that. You may have, in the past, been told that 22/7 is pi, but in fact, 22/7 is only an approximation of pi. And so I'm going to use these squiggly lines instead of an equal sign. I'm going to do these squiggly lines. These squiggly lines means it's approximate. It's an estimate. But pi, 3.14159 dot 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 forever, is not exactly 22/7, even though 22/7 is a good approximation. 22/7 is a rational approximation of a very irrational number. There are many, many irrational numbers out there, countless. And we will start to explore some of them. Thanks.